Every year, more than 10 tons of coffee grounds are discarded by factories. Massive trucks deliver compressed coffee grounds to the automated receiving station. Hydraulic lifts unload the containers into giant stainless steel receiving hoppers. Huge conveyors transport the raw coffee grounds deep into the factory. Industrial scales automatically weigh every batch with exceptional precision. Robotic arms remove contaminants before processing begins. Multiple conveyors and pipelines operate together across the enormous production hall. Powerful crushers break the compressed coffee blocks into smaller pieces. Vibrating conveyors evenly distribute the material before drying. Massive rotary dryers remove moisture using continuous streams of hot air. Heavy-duty motors slowly rotate the giant drying drums without stopping. Inside the dryer, lifting fins tumble the coffee grounds through hot airflow. Engineers monitor temperature and humidity through advanced PLC control systems. The dried coffee grounds leave the rotary dryer with ideal moisture content. They are now fully prepared for the next stage of premium bioplastic production. Perfectly dried coffee grounds move onto a cooling conveyor for stabilization. Powerful exhaust fans remove heat and moisture from the production line. Screw presses extract valuable coffee oil from the processed coffee grounds. Massive steel screws compress the material under extremely high pressure. Rich coffee oil flows continuously into stainless steel storage tanks. Precision flow meters monitor every drop moving through transparent pipelines. The remaining coffee fiber enters powerful hammer mills for fine grinding. High-speed hammers turn the fiber into ultra-fine coffee powder. Vacuum conveyors transfer the powder into massive sealed storage silos. Automated sensors continuously monitor the amount stored inside each silo. The material enters giant industrial mixers for the compounding process. Automatic dosing systems precisely combine coffee powder with bio-based polymer. Crystal clear PLA pellets pour into the mixer like a flowing waterfall. Giant mixers blend both materials into a perfectly uniform composite. Engineers supervise every batch from the centralized control room. Engineers monitor the compounding process through advanced SCADA control systems. Precision pumps inject liquid additives to improve strength and durability. The finished mixture moves into enclosed screw conveyors automatically. Sealed conveyors deliver the material directly to the extrusion department. Multiple industrial mixers operate together at full production capacity. Viscosity sensors ensure the mixture remains perfectly consistent before extrusion. The material enters a gigantic twin-screw extruder for processing. Powerful twin screws compress and heat the material continuously. Heating zones gradually raise the temperature to 190 degrees Celsius. Inside the extruder, the material is kneaded into a uniform composite. Dozens of molten strands emerge together from the massive extrusion die. Each glossy strand flows smoothly like molten glass under pressure. The hot strands enter a long water cooling system immediately. Stainless steel guide rollers keep every strand perfectly aligned during cooling. The complete extrusion line demonstrates the factory's enormous production scale. Powerful air knives remove every remaining drop of water before pelletizing. Multiple extrusion lines operate continuously across the enormous production facility. Engineers monitor pressure, screw speed, and temperature in real time. Parallel production lines demonstrate the factory's massive manufacturing capacity. Quality technicians inspect every strand using precision digital calipers. High-speed pelletizers cut the strands into perfectly uniform plastic pellets. Vibrating screens separate every coffee bioplastic pellet by precise size. Millions of finished pellets flow through polished stainless steel transfer channels. Pneumatic conveyors transport the pellets into towering storage silos automatically. Automated sensors continuously monitor material levels inside every storage silo. Sampling systems collect pellets for laboratory quality inspection. Advanced instruments verify pellet size, moisture, and overall consistency. Robotic arms stack finished coffee bioplastic bags onto shipping pallets. Engineers prepare advanced equipment for strength and heat resistance testing. The first laboratory test compares coffee bioplastic with conventional plastic. Precision sensors measure deformation under extreme heat in real time. Massive hydraulic presses apply enormous force to coffee bioplastic samples. Digital load cells record pressure throughout every compression test. Coffee bioplastic bends slightly without cracking under heavy compression. Automated drop testers release both samples from the same height. The coffee bioplastic container lands intact after striking the steel platform. Conventional plastic shatters instantly under the exact same impact conditions. High-speed cameras capture every moment for detailed performance analysis. Advanced computer systems compare impact resistance and thermal performance automatically. Quality reports confirm the coffee bioplastic meets strict industrial standards. Certified pellets enter automated injection molding machines for final production. Robotic arms transfer newly molded products onto cooling conveyors. Automated packaging lines seal, label, and barcode every finished product. Driverless. AGV vehicles transport finished pallets into the massive warehouse. Coffee waste becomes premium bioplastic, powering a cleaner and more sustainable future.